So now we need to check odd, even, or neither properly. We don't want to just rely on a graph. For example, we may not have a graph in front of us. Finding the graph could be very complicated. So we've got a few shortcuts, but I don't want to use them. One of the shortcuts is if I have a polynomial, all of which whose exponents are even numbers, for example, squares, power fours, that kind of thing, power zeros, then you are an even function. And similarly, if all of your exponents are odd, I mean all of your exponents, then you're an odd function. So the first example here, the exponents are 3 and 7. That's both odd numbers, so that actually means it's going to be an odd function. But let's check it carefully. I don't want to just rely on this. So I want to kind of really carefully get this done. So let's call this guy f of x. So I need to see what happens when I feed in minus x. And I need to see if it's equal to f of x or minus f of x. So this is equal to minus x to the power 7 plus minus x to the power 3, of course. Minus x to the power 7, though, is just minus x to the 7, because it's minus 1 to the 7 times x to the 7, and minus 1 to the 7 is just minus 1. Minus, same story here, this. That's equal to what? Minus f of x. So this implies the function is odd. B. That's true for anything in the domain. Now this guy, easy to mess stuff up, so I'll call this gx. This is a degree 5 polynomial, but I kind of know ahead of time it's not going to be odd or even. The reason is there's a mixture of odd or even number exponents. We've got a 5 here and a 2 here. One is odd, one is even. So I have a bad feeling about this. I don't think it's going to be odd or even. To check something's not odd or even, all I've got to do is find one specific place where it fails. Let's just try minus 1 and see what happens. So if I do minus 1, this is equal to minus 1 to the 5 plus minus 1 squared. Minus 1 to the 5 is minus 1. 1 squared is 1. It's equal to 0. G of 1, though, what's that equal to? Well, that's equal to 1 to the 5 plus 1 squared. That's equal to 1 plus 1. That's equal to 2. So said together, we definitely know that g of minus 1 is definitely not equal to plus or minus g of 1, which is what I would need. If I was even, it would be plus. If it was odd, it would be minus. So what do we conclude? Neither odd nor even. And the last case, same story. I don't see any reason ahead of time why it should be odd or even. So let's just test a point. Let's do 1 again. 1 and minus 1. So let's do h of minus 1. That's equal to what? 1 divided by 5 to the minus 1. So what's this equal to? Basic algebra. This is, it's reciprocal. It's going to be equal to 5 to the 1. Negative of negative 1, that's equal to 5. And then let's do h to the 1. That's equal to 1 over 5 to the 1. That's equal to 1/5. Okay, yeah, definitely not. In this case, h of minus 1 does not equal either plus or minus h of 1. So it's neither odd nor even. So only the first example is. So we did this algebraically, checking really the proper definition really carefully. So neither odd nor even. So it's incredibly important you're able to do that. You need to understand that, sure, odd and even means something in terms of the graph, a certain symmetry with respect to rotations or reflections, but the actual meaning is to do with what happens when I feed in minus x. Is it plus or minus the output for x itself? And if you're not sure, just chuck in a few values. You'd be pretty unlucky to randomly select a value where it worked. Just as a silly example, for b, right? If I was being crazy, I'd be like, oh, well, let's just feed in 0 and see what happens. But that's completely crazy, right? It's pointless. Because if I did g of minus 0, of course this is equal to g of 0, because minus 0 is equal to 0. So you might think, oh, it's going to be even. But that's no good. It has to be true for all possible x, not just a single one. So if you do a value and you get the symmetry property turning up, maybe do one more just to check to see if it was a complete fluke. You'd be very unlucky. And if it works as well, then it's probably true. And then you want to do a general argument like part A here.